Already we have some idea. Yesterday class we have checked it. No, we did for hollow hemispherical shell. No? Also hemispherical shell we did. Now I'm asking for this one. So it will be the structure. It's a three-dimensional object I'm showing. So this will be the base. Coloring all it's taking a lot of time. I'm just give a rough diagram here. Is that okay? No. So this will be the sufficient. So now we have to look at the center of mass of this. So what best we can assume here is what this solid hemisphere to be made up of. Hemispherical shell of increasing radius. Hemispherical shell of increasing radius. I'll give plain diagram. Hemispherical shell of increasing radius. So let this be equal to R thickness of this, dr mass of this, let it be dm. What is the total radius? Total radius is capital R. What is this? Thin hemispherical shell. I think you know what is the center of mass for this thin hemispherical shell. It should be at what distance? For this thin hemispherical shell, it should be at a distance of r by 2. This is for not hemisphere. For hemispherical shell, it is I'm talking about this one. So now let's go for this one. Solid hemisphere. Is it a like a 3D object or 2D object? It's a 3D object here. That one. So let rho be the density. Now let me define the mass dm. What's be the mass of that hemispherical shell? dm should be equal to rho into surface area of that 2 pi x square dx. So then what is rho? How you define mass by 2 by 3 pi r cube? No, so 2 pi x square dx. So dr I took it. I'll make it small r. So I have this much here. So this will become, so altogether the value of dm is equal to 3m by 2 pi will cancel out. So r cube will be left over. So here r square dr. No. So we know mass here. So can we define now the center of mass of the system? dm we know. So where the center of mass will be at a distance r by 2. I think I'll take it out this capital R. Center of mass of what? This one? Center of mass of hemispherical shell. We have to calculate center of mass of this solid hemisphere. So where do it lie? It will be, we have to locate its center of mass. Okay, get this one. Now, what is again the formula? RCM equal to integral of, what is the thing? Of this hemispherical shell where the center of mass is at a distance r by 2. I think this bracket term is very important. Into mass by this one. So what should be the limit? 0 to capital R. That bracket r by 2 is something very important. Now let's come for dm. dm is how much? 3m by r cube r square dr. Total mass, let it be m. So here r cube will come outside. So 3 r cube 3 by 2. So this will be r cube dr, 0 to capital R. 3r to power of, or 3r by 8. From where? From the base. So this is what? That 3r by 8. I'll show it here. So like this, all this you are supposed to remember. Huh? No, disk. If you choose the disk again, disk of varying radius, you have to bring it. No, lot of calculations. I made things very simple. Okay, similarly, we'll go for solid cone.